Power of K-fold cross-validation, the AI mind at work. AI model by Pradeep K. Suri. Brain what the image represents. The video provides beautifully visualizes K-fold cross-validation, K equals 5, styled as an intelligent systems learning and reasoning process almost like an AI brain executing iterative thoughts. Here's a breakdown from an AI/ML perspective and how it mimics cognitive learning. How K-fold cross-validation works. K-fold CV is a technique that divides the data into K equally sized folds. Each fold is used once as a validation set while the remaining K1 folds are used for training. In the image, folds 0 to 4 represent different validation rounds. Each line, color-coded, represents how the model is trained and validated across those folds. Formulas, like E equals mc superscript 2, indefinite integral f, x, dx, f equals ma, etc., metaphorically show knowledge being transferred representing various domains, physics, calculus, algebra, just like an AI learns across varied data sets. AI mind interpretation. Imagine the AI model as a student preparing for an exam. Step AI thought process, like a brain. Train on fold 1 to 4, validate on fold 0. Let me learn from most of the book and test on a new chapter. Train on fold 0, 2, 4, validate on fold 1. Now I skip another chapter and see how well I understand it. Repeat for all 5 folds. After testing every chapter individually, I'll average my performance to know how well I truly learned. This repeated exposure to new unseen data, validation folds, strengthens the model's generalization just like an AI getting smarter with diverse experiences. Why this is powerful, post-training insights. Benefit AI mind analogy practical outcome. Robustness learns from different angles model is not biased to one dataset split. Better generalization handles unseen scenarios performs well on new, real-world data. Balanced learning no overdependence on any subset reduces risk of overfitting. Performance estimation multiple evaluations more reliable accuracy metrics. AI explainability repeated exposure equals deeper understanding insight into feature impact and model behavior. Post-training for unseen data. Once K-fold CV completes, the final AI model is trained on the full dataset. Since it was tested multiple times on unseen folds, it's now ready for real-world data. Think of this as a well-practiced AI mind trained under varied conditions, ready to predict outcomes accurately for unseen situations. Summary. Brain K-fold is like a multi-angle simulation of the human brain's learning process. It tests, adapts, and self-improves, becoming resilient and intelligent. After K-fold, the AI is equipped to face reality with confidence. It's no longer memorizing, it's truly understanding. Would you like this explained in a PPT format or embedded in a AI training dashboard as well? In the ERP domain of the process industry, applying K-fold cross-validation to AI/ML models allows generation of strategic, tactical, and operational level reports and graphs across top management, middle management, and operational level. These insights help in enhancing production efficiency, quality control, supply chain accuracy, and resource optimization. Reports and graphs from K-fold, ERP, process industry. Here's a sample Python program result using Plotly with a dark background to simulate an AI model ROI projection for a process industry, highlighting business-level cost savings derived from improved predictive accuracy, such as reduced energy usage and rework costs. Python program, AI model ROI projection, business-level cost savings. Author, Pradeep K. Suri, author, researcher, and AI/ML architect. Explanation of the image, AI model ROI projection using random forest, K-fold validation. Title, bar chart AI model ROI projection, business level cost savings from predictive accuracy, model by Pradeep K. Suri. Brain AI model architecture, random forest with K-fold cross-validation. Deciduous tree. What is random forest? Random forest is an ensemble machine learning model that builds multiple decision trees and averages their predictions. It is powerful for classification, example defect versus non-defect batches. Regression, example predicting energy consumption, rework cost. Repeat button. How K-fold cross-validation is used. K equals 5 folds were used to split the process industry data. Each fold trained the random forest model on 4 subsets and validated it on the 5th subset. The result is 5 independent evaluations of the model's performance and ROI metrics. Chart increasing understanding the graph. Bar chart. Bar charts. Each fold reports 2 types of business savings. 1 blue circle energy savings, INR LOX. Represents cost reduction from AI-optimized machine scheduling, motor runtime, or heating/cooling processes. 2 green circle rework cost reduction, INR LOX. Derived from better quality predictions reducing scrap, reprocessing, or rejected batches. Example. Fold 3. Energy savings, 5.1 Indian rupees LOX. Rework reduction, 3.2 Indian rupees LOX. Total savings, 8.3 Indian rupees LOX. Chart increasing yellow line, total ROI per fold. A line chart overlays the bar graph to show cumulative benefit, total savings. Helps track which fold produced the most favorable cost outcome. Magnifying glass tilted left. What this graph tells top and middle management. Insight interpretation. Fold-wise ROI stability. Most folds, fold 2, 3, 5, show consistent ROI 7.5 Indian rupees LOX. The model is robust. Fold 5 peak. The AI model reached its highest accuracy and savings in Fold 5. Performance drift in Fold 4. Slight dip, 7.4 Indian rupees LOX, may indicate validation data variation, hinting at real-world unpredictability. Generalization across folds. The model generalizes well, with savings consistently increasing, except one dip, showing predictive confidence in unseen data. Factory business level outcomes from Random Forest AI ROI. Area of savings. Root cause prediction by Random Forest. Energy optimization predicts machine overuse, unnecessary load. Rework cost avoidance flags process deviation early, example temperature, viscosity outliers. Downtime minimization predicts failure risk and enables preemptive action. Inventory and waste control forecasts overproduction or scrap likelihood. Quality control identifies fault patterns leading to batch failures. Direct hit decision support applications. Small blue diamond for top management. Predict and validate cost avoidance potential via AI. Prioritize funding of AI projects with the most impactful fold metrics. Guide strategic automation investments. Small blue diamond for middle management. Evaluate model consistency across folds. Justify change in process flow or equipment calibration. Plan next phase of AI deployment. Summary. The graph visualizes how a random forest AI model, validated using 5-fold cross-validation, has generated tangible cost savings in energy and rework. Each fold reinforces model reliability and its real-world business impact in the process industry ERP ecosystem. Other reports and graphs from Random Forest Model, K-fold. Office Building 1. Top Management Reports. Purpose, Strategic KPIs, ROI from AI, Quality Forecasting, Compliance. Bar Chart Report/Graph Description. AI-driven production efficiency report. Overall performance trend across folds showing predicted versus actual throughput or downtime. Yield forecast accuracy chart. Average K-fold accuracy for yield prediction and raw material efficiency. Risk heat map for plant units. K-fold generated failure prediction zones by process line or plant section. AI model ROI projection. Business level cost savings from improved predictive accuracy, example energy savings, reduced rework. Strategic quality scorecard. K-fold metrics for predicting and reducing nonconformities, QC failures. Regulatory compliance forecast of batch compliance issues flagged by fold level validation performance. Visuals. Heat maps, QC risk zones. KPI bar charts, fold averaged. Sankey diagrams, data to cost savings. Radar chart, cross KPI fold performance. Office Worker 2. Middle Management Reports. Purpose, Model Diagnostics, Production Planning, Feature Tuning, Material Forecasting. Bar Chart Report/Graph Description. Fold-wise model accuracy curve accuracy / loss for predicting cycle time, downtime, or waste per fold. Material consumption forecast by Fold K fold-based AI predictions for material usage versus actuals. Confusion matrix for batch quality prediction fold-wise breakdown of good versus defective predictions. Shift-wise process anomaly forecast pattern detection across time / folds identifying process drifts. Hyperparameter impact chart comparison of tuning results fold-wise to optimize AI models. Machine / line efficiency variation fold-wise model output for machine-specific predictions. Visuals. Line and scatter plots. Confusion matrix heat maps. Multi-bar charts, machine or shift-wise. Fold-wise rock and precision recall curves. Construction worker 3. Operational level reports. Purpose, fault prediction, data QA, fold assignment tracking, real-time insights. Bar chart report / graph description. Train / test split report by product batch shows which batches were used for training or validation per fold. Data integrity report missing / null / duplicate detection per fold, input QA. Sensor error prediction graph real-time sensor anomaly detection learned across folds. Feature importance variation how critical process features vary in importance across folds. Actual versus predicted runtime for cycle time or energy usage by equipment. Operator error impact report fold detected deviations correlated with operator activity / logs. Visuals. Strip plots for anomaly data. Heat maps for sensor / feature issues. Sankey diagrams for data flow per fold. Histograms for batch level metrics. Brain end-to-end insight flow, K-fold perspective in ERP. Phase output type target level. Model accuracy, loss, rock middle, top. Forecasting precision yield, energy, cost curves all levels. Anomaly and failure fault zone heat maps operational, middle. Compliance and quality regulatory, ISO reports top. Resource utilization material, labor, machine charts middle, operational. Dashboard integration fold by fold metrics, Plotly /dash, all levels. Hammer and wrench bonus, recommended dashboard widgets. Widget title level. Fold-wise model confidence tracker middle / top. Process line forecast accuracy tile middle. Cost avoidance graph, AI prediction, top. Defect probability radar, QC, top / middle. Operator deviation Sankey operational. File folder output formats. Bar chart Plotly dashboards, with dark / light mode. Page facing up executive PDFs. Chart increasing live KPI boards, fold-wise. Open file folder Excel exports by fold. Thank you.